Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. Respected judges, my name is Ihsan Yassin from the Microwave Research Institute, UITM Malaysia. My co-researchers are Bapak Syairul Amin Megan Ali, Azli Zabidi, and Prof. Noritawati Muhammad Tahir. We are here to present our project entitled Copyright-Free Artificial Intelligence Image Synthesizer. Let's begin with the problem statement. In many websites, images help make the websites more attractive. And there are many images available on the internet. However, many of them are protected by copyright. If we use these images, we are liable to be sued by the original content creator, and this creates a problem where we need to have original images. However, we cannot use use any of the images on the internet. Because of this, we are proposing an artificial intelligence-based solution which can generate images that are copyright-free, and these images are created based on samples from copyrighted images. So basically what we are doing now is that we are collecting a lot of copyrighted images, and using using an AI based solution, we train the AI to create new art which are copyright free based on the works from the copyrighted images. So the proposed solution here is to design an AI based system to generate copyright free images for website design. The particular method that we are using here is called the Generative Adversarial Network, or GAN, where GAN is used to synthesize, to create new images automatically after being trained on samples. One advantage of this method is that it can generate as many images as you want, and they are all copyright free. So you can use it on your website, on your, let's say if you have a graphics company, you want to create a poster, you want to create a card, you can use this image and you can produce as many as you want. Okay, you can just pick and choose. Let's say if you want to generate a design at your publishing company or a design company, what you can do is that you can just on a click at a click of a button, you can generate maybe 1,000 images, and then you can just pick and choose whichever image you want, and they are all copyright free. Another advantage is that this technology, the GAN technology, can also be customized to create other images as well. So for this particular project, I am using abstract images to train the neural network, to train the GAN. However, you can use other types of images as well for the GAN to learn and create those new samples as well. For example, if you want to create a bunch of cat images, you can collect all the cat pictures you want from the internet, okay? and you can train the gun to create new images of cats, which are quite which are based on the training from the sample images, and it can generate new cat images, which are all copyright free. So that's the advantage of this particular project. A little bit on the concept. As I mentioned before, the technology behind this project is called the Generative Adversarial Network, or GAN. This GAN actually is a learning machine, which is comprised of two networks, two neural networks, we call it. Neural networks are basically learning machines, and these neural networks are called the generator and the discriminator network. Firstly, the generator network is a neural network that accepts random values or noise vector, and based on this noise vector, it will produce fake images. These fake images are then sent to the discriminator together with the original images that we have collected earlier. And what this discriminator does is that it tries to distinguish between fake and real image. So at first, during training, probably the discriminator and generator networks are trained simultaneously together. Okay, so the more we train these networks, the better they get. So the generator gets better at producing better fakes, and the discriminator gets better at detecting whether an image is a fake or not. So based on this competition between those two networks, the end result generates the fake images that are as realistic as the real thing. And since it's generated by a computer, there is no issue regarding copyright and so on and so forth. A little bit on the methodology, how we did this. The hardware used for this computer, for this project, is the AMD Threadripper CPU with 64 gigabytes of RAM and 4 GPUs. If you are not familiar, most projects involving AI now require the use of GPUs to perform the calculations, because the calculation is very massive, it's overwhelming. And without these types of GPUs, the computation time, the training time for the gun will be very slow. So for our case, we used 4 GTX 1080 Ti GPUs to train the gun to generate the abstract images. The samples for the abstract images were collected from stock image websites. We looked for images on a few stock image websites, and after some searching, we ended up with around 50,000 images. Those images were resized to 1024 times 1024 pixels using bilinear method to preserve the details. So even though we have a very big image, if we shrink it down to around 1024 pixels, the details inside the image would still be present. And once we have all these images, we start to train the gun. The code was written in Python, there's actually one very good implementation of gun called the lightweight gun, published in 2021, and we use that structure, the architecture, to perform this experiment. We trained it to 200,000 epochs, and we used automatic mixed precision method to improve the speed. Basically, what AMP does is that it reduces the number of calculations by reducing the precision of the numbers used for the calculation. So let's say the numbers, the numbers generated in the during training, the precision is high. We reduce it a bit so that we can improve the speed. After training was performed, we synthesize images and we validate the quality of them. Training took approximately 1 week to complete. This is due to various factors. Some of them, the number of images used for training. With AMP, we managed to reduce the time. We can also improve the time to train by resizing the samples. That's why we resize the samples to 1024 times 1024. After all that, we took around 1 week to complete. These are some of the samples used for training that we collected from many websites. These are human drawn images, so all of these are copyrighted. And what we did was we took all this and we gave it to the gun for it to learn what is the meaning of art. Okay? And based on that, it will generate its own kind of art based on these samples. Initially, during training, we can see that at 0 iterations, the generated images are not very good yet. However, as training progress, we can see that some of the images have started to become something like abstract art from the original samples. Okay, so as the training progress, we can see more and more improvement up until 200 iterations where it has generated these kinds of images. And the generated images, some of the generated images are shown here. As you can see, there's a lot of variety in terms of color and in terms of the things being drawn by the gun. Okay, some of it is quite nice, others not so much, but hey, it's art, so art is very subjective to everyone. Some of these pictures I consider pretty, some not so much. So it's up for you to interpret this art being generated by the gun. What's good about this is that everything here is copyright free, so you can use them in your website without any legal issues whatsoever, because it's generated by the computer. So with that, I would like to thank you. Do consider us for an award in IIC 2020. Thank you very much.